Okay, now I want to talk about methods. And here's where it's maybe going to be a little helpful if I actually write some code in a script here so I can reuse it. So I guess I'll call this maybe method test.py. Okay. So a method in Python, it's very similar to methods in Java or C++. The syntax, though, is a little different. So you say def, that means method. So that's starting a method. Just for a very simple example, let's say a method that returns the quadratic formula. So I'll say quadratic roots. So I'll say A, B, and C, right? So I'll say something called the discriminant equals, so it's quadratic form is negative b plus or minus square root of b squared minus 4ac all over 2. So the discriminant is something called b squared minus 4 times a times c. And so I'll say left root equals negative b minus, minus square root discriminant. So this is, you can do square root, by the way. You can raise to a fractional power. So that should be all over 2 times a. And then the right root should be negative b plus the discriminant, square rooted over 2 times a. And then I can return the left root and the right root. So notice I'm returning a list here, actually, with these variables in it. So this is going to return the quadratic roots for both the left and the right root. Okay. Anyway, so this is a full example of a method. And what I'm pointing out here is, okay, this returns a list, but I didn't have to say returns a list. I didn't have to specify a return type. You always just have to say def, so that's really nice. And same thing with the parameters. I didn't have to specify what type of parameters they were. They could be floats, they could be ints. They should be probably numbers because this is the quadratic formula. If I try to pass strings to this, it might not give me an answer that makes a whole lot of sense. Let's see, actually, if I run this, it's now this method's going to be accessible to me. So I can say quadratic roots. Let's say we're looking at the equation, maybe x squared. So if I had the equation x squared equals 4, then that would translate into f of x equals x squared minus 4 equals 0. You may or may not remember this. I'm just trying to. So in this example, a is equal to 1, b is equal to 0, and c is equal to negative 4. Okay, so the roots of this should be 2 and negative 2. So let's see if that happens. So let me put in 1, 0, negative 4. Okay, so cool. So I get negative 2 and 2 as a list there. So see how easy that was? I didn't have to say returning a list of these types, the types come in. That's it. I just say, A, B, C. Now the one thing that's very important, that's a little different, is so we don't have these curly braces in Python. We have a colon, and then that says, okay, this is a block of code after that colon. Blocks of code need to be tabbed over. So if I try to do this, it's gonna say expected an indent on block, and it's not even gonna let me run it. So everything that's indented is a block of code. So, and it belongs to whatever the colon is up there. Okay, so this stuff all belongs to quadratic roots. Okay. Now one more thing I just want to say real quick. It's a convention to write these things called doc strings. Remember I told you the way to do a multi-line comment is by using these. This is technically a string, actually. But anyway, so it's a convention to actually say what you expect the types to be. So I'll say, my parameters are a, which is an int, so that's first coefficient. B, which is also, and they don't have to be ints. I guess we'll just say number. So we're telling the person who's going to use this code what to expect. And then we can also say what it returns. And actually, if you do this, you can generate very nice web pages that will automatically format this to look very nice as documentation for your code. So we'll say return a number which is the root, or actually no, we're returning a list, root 1, root 2, which is the two roots of the quadratic equation. Okay, so this is all comments, but it's helpful for us to say what it does. So I'm also going to put a description up here. Okay, so nothing has changed because it's just a comment. Let's real quick see what happens if I try to send something that's not a number. Let's say I just say string A, string B, string C. How much is this going to get messed up here? Right, so it crashes because it doesn't know how to exponentiate a string. So what does it mean to raise the string A to the second power? It doesn't define that here. All right, cool. So that's the basics of methods, and that's really all that there is to it. So now you can start to make blocks of code that do things and reuse them. So this is our first way of having reusable code. Okay, but I want to look now and think about conditional statements. So control flow and branching. So let's make another method. I'll call it even or odd. And it'll take in a number. And so what I wanted to do, so I get into the habit of actually, before I write any code, actually writing my doc strings. So I want this to say return whether a number is even or odd. So we'll say we have one parameter, x, which is a number. So it's the number we're testing. And then we return true if x is even. So let me actually change the name of this. I'll say is even. So we'll say true if x is even, false if x is odd. Okay. So I actually now have a branch in my code. It's not always going to do the same thing, right? If x is even, it's going to return true. If x is false, it's going to if x is odd, it's going to return false. So we actually have to do something different based on what x is. So here's where we branch. So we're going to use if statements just like we did back in other languages. So I'll say if x mod 2 is 0. And just like the method, I have a colon. And within there, so let me say result is true. Actually, let me say result equals false. So we'll assume that it's odd, but if we find that when dividing it by 2 it has no remainder, then we'll make it even. We'll say that's true. And then at the end we'll return result. Okay, so that's all there is to it. So let's just test this real quick and then I'll talk a little bit about it. So if I say is even 200, that's even. If I say is even 71, false. Okay, so that seems like it's working. And so what I want you to notice is just like we had to tab everything over to be inside the method, we also had to tab everything over that was inside the if statement. So that's what you get instead of curly braces. So it makes the code a little shorter. You just have to be careful with your tabbing. So let's say I had a couple things in this if statement. So here's where you can get into some trouble. So let's say I said executing if statement. All right. So let me run this again. It'll overwrite the method. So I'll say is even. I'll say 20. Okay, so cool. So we're executing the if statement, and it's eventually saying the result is true and it's returning true. But if I accidentally tab this over, this is no longer in the if statement. Okay, I know that the code looks exactly the same, but because it doesn't align with the tab here, this is not assumed to be in the block of the if statement. So if I do this again and I say is even 20, okay, that seemed like it was okay, but what if I now say is even 21? 21 is definitely odd, right? So it returned true. So if you trace through this code, what you'll see is, well, it assumes that it's odd. It doesn't actually execute this if statement. But because this is not in the if statement, it's always executed. So be very careful with your tabbing. That's the take-home message here. Okay. Now, what if there are multiple conditions you want to check? So let me show you an example here. So here's an example that I made when I was teaching a Python class last spring. So what if we want to have a method that prints stuff out about how severe an earthquake is? So this program actually is going to take an input here. So this is how you get an input. Use this method called input and then feed it into float, which makes it a real number. So let's say I had an earthquake that was a 6 on the Richter scale. So it's going to say many buildings are damaged. Okay, so if you're greater than or equal to 6, many buildings are damaged. It's also true that all these buildings are damaged as well. Let's try to run this again. So let's make it a 7.5 on the Richter scale. That's pretty bad. So it's going to say many buildings collapse. If you are greater than 8 on the Richter scale, greater than or equal to 8, then everything collapses. Okay. So what you're noticing here is these Boolean statements are just like they are in Java and C++. So this is a greater than or equal to. So we had our equal, we had our equals here, which was checking for equality. We can also have greater than or equal to, which checks for just that. Okay, and we can also have less than or equal to. The other thing you notice here is that this is like if, else if. So in Python it's called elif, not else if. And you can have this, I always think of it like a sandwich. So you have if, and then you have a bunch of elifs, and then the bottom of it is an else if you want. Okay, you don't always have to have an else, but you can. So this is the syntax in Python. Hopefully you're familiar with if statements and else statements and things like that. And again, just notice that within each if or else, you're always tabbed over for what happens when that's true. So for else ifs, we keep going until we get one that's true. So when I inputted a 7.5, this one was false. So I went to the next one. I said, okay, it wasn't greater than or equal to 8. Otherwise, is it greater than or equal to 7? Yes. And as soon as I get one that's true, I'm done. I jump to the end of the whole thing. If I put in a 5, then what's going to happen is it'll start here. It'll say, okay, is 5 greater than or equal to 8? No. Otherwise, is 5 greater than or equal to 7? No. Otherwise, is 5 greater than or equal to 6? No. Otherwise, is 5 greater than or equal to 4.5? Yes. Okay, so only poorly constructed buildings are damaged if the earthquake is a 5 on a Richter scale. Okay. Now, just to remind you, there's a pitfall you can end up in with ifs and else ifs, which certainly also would happen in Java or C++. So the difference between these two pieces of code here is that instead of using else ifs here, I just said if Richter's greater than or equal to 8, do that. If Richter's greater than 7, do that. So let's see what the difference is. So let's again put in, let's say 7.5. Okay, now so if the Richter was 7.5, I really only wanted to print out that many buildings collapsed. But because I didn't have the else if, it kept going. It didn't break out once one of these were true. So it's true that 7.5 is greater than or equal to 7, but it's also greater than or equal to 6, and it's also greater than or equal to 4.5. So just make sure that you're using else if. This is a common mistake when people are learning how to program. If you only want one of the things to execute. All right. So that's it for methods and conditionals and how to make blocks in Python. So be very careful with your tabbing. I can almost guarantee that you will make some kind of mistake with tabbing at some point. So just pay really close attention and make sure that every time you start a block, you immediately tab yourself over. The editor tries to help you with that. So notice that I thought I was still typing something in here when I hit the return, so it kept me tabbed that way. But if I break out of this, I want to make a new one, so I say if 2 is 2. Notice it tabs me over right away. So the editor tries to steer you on the right lines, but it's still possible to mess it up. Okay, so I'm gonna have you do a quick exercise with leap years, which again was a 173 exercise, but we're gonna try it again in Python. And so it'll get you to practice this methods and these Boolean statements, if statements with Boolean expressions. Actually, and the one last thing I should say is we can have compound if statements. So let me just give a quick example of that. So let me say, I can say something like S equals Chris. So I could say if S at index 0 is a C and S at index, the last element is an S, then I'll say print ends or starts in C, ends in S. So let's just try this real quick. I'll call it compound. Actually, sorry, these should be characters. Whoops, no, sorry, capital C, that's what it was. Capital C, not lowercase c. There we go. So starts in capital C, ends in S. So all I'm showing you is this was supposed to be, in C++, this would read something like, or in Java, it would say if, s.char at 0 is equal to C and s.char at whatever the index was here. Not -1, but this ends up being closer to English here. So that's one really nice thing about it. So instead of writing 2 ampersands, you write and for or, you just write the word or. So, and then for not, you write it not. But also for equals, you can do not equals. So say does not end in S for this example. Okay, so it didn't happen there. If I change it to Chris, now it's true. So it starts in C, does not end in S. Just to show you using the not keyword, I could also put this all in parentheses and say, okay, the first character better be equal to C, but it better not be the case that the last character equals S. And that works as well. So all I'm telling you is this is exactly like it would be in Java or C++, except the words that you use are generally much closer to English. Okay. Now we're ready for the exercise. Cool.